Hello everyone, welcome back to my YouTube channel. So today I'm here to discuss about the topic stack operations. So let's get started with the introduction. A stack is a linear data structure that follows the last in first out principle where the elements are added and removed from the same end known as a top. It is an essential part of the data structures and algorithm and finds application in various fields such as expressing parsing, function call handling, and undo redo functionalities. Definition of a stack. A stack is a collection of elements with two main operations: push, which adds an element to the top of the stack, and pop, which removes the top element. It follows the last in first out principle, where the most recently added element is the first to be removed. Last in first out principle. In last in first out principle ensures that the most recently added element is the one to be removed first, similar to how items are stacked in the real world scenarios. Push and pop operation. The push operation adds an element to the top of the stack while the pop operation removes the top element, effectively modifying the stack size and content. Array implementation, representing stack using arrays. Array can be implemented using arrays where elements can store in contiguous memory locations. However, this implementation has limitations such as fixed size and potential overflow and underflow condition. Apply implementation of a stack has limitation related to its fixed size, which can lead to the overflow when the stack is full and underflow when attempting to pop from an empty stack. The time complexity of a push and a pop operation is an array-based stack is 0 of 1, which indicating that these operations have constant time complexity regardless of stack size. Linked list implementation, representing stack using the linked list. A stack can also be implemented using the linked list, providing a dynamic and memory effective approach. Linked list implementation offers flexibility in managing elements without concerns of overflow or fixed size. The use of linked list for stack implementation allows for dynamic memory allocation, effective space utilization, and the ability to add or remove elements without constraint related to fixed size. This time complexity of push and pop operation is link-based stack is 0 of 1, offering constant time complexity using the array-based implementation. Application of stack. Stacks are utilized in evaluating arithmetic expression by converting them into postfix notation and then using a stack to perform the computation. This technique is especially useful for complex mathematical expression. Function called stack. In programming, the function call stack uses a stack data structure to keep the track of function call, parameters, and local variables. This allows for the sequential execution of function calls and their respective contexts. Undo redo functionality. Stacks enable the implementation of undo and redo functionalities in application by storing the state of actions as they are performed. This allows the user to backtrack through their actions or redo them as needed. Stack limitation, memory limitation. Stacks have limited memory allocated for their operation, and exceeding this memory limit can lead to the memory overflow or underflow. Overflow. Stack overflow occurs when the stack exceeds its maximum capacity, leading to a memory allocation error and potential program crash. Underflow. Stack underflow occurs when a pop operation is attempted on an empty stack, resulting in an underflow error. Stack usage guidelines. When to use a stack. Stacks are suitable for solving the problems that involve backtracking, function call management, parsing, expression evaluation, and undo or redo operation. It's important to use stack data structures judicially and ensure problem management of memory location to avoid stack overflow and underflow. Additionally, implementing error handling for boundary cases is crucial. Infix to postfix conversion. The algorithm for converting infix expression to postfix notation using a stack involves scanning the input expression, using a stack to store the operator, and determining the order of operations based on the precedence of operator. The resulting postfix expression is evaluated using the stack-based operation. Postfix evaluation. The algorithm for evaluating postfix expression using a stack involves iterating through the postfix expression using a stack to store operands and performing arithmetic operation based on encountered operators. The final result is obtained after processing all the elements in the postfix expression. Stack complexity analysis. The time complexity of a stack operation such as push, pop, peek, and isEmpty is 0 of 1. This means that these operations take constant time irrespective of the number of elements in the stack. Space complexity. The space complexity of a stack operation and implementation is 0 of n, where n is the number of elements in the stack. This linear space requirement grows with the number of elements stored in the stack. Stack versus the other data structure. Stack versus queue, which while a stack follows the last in first out principle, a queue follows the first in first out principle. Stack versus the linked list. A stack restricts elements insertion and deletion to the top, whereas a linked list allows elements insertion and deletion from any position. Stack versus array. In a stack, the size is fixed, that is static memory allocation, or dynamic memory allocation, while an array has a fixed size, that is static memory allocation and contiguous memory allocation. So let's see a few real-world examples. Backtracking algorithm. Backtracking algorithms such as classic NQ's problem often utilize stacks to store the state of each step of exploration process. Expression evaluation. In compiler, design and mathematical computation, stacks are used to evaluate and compute nested expression effectively. So let's see a few common mistakes. Effective error handling is essential to manage scenarios such as stack overflow, underflow, and invalid operation. Proper error handling ensures graceful recovery and avoids unexpected program termination. So let's come to the conclusion. A summarized review of the key concepts related to stack operation, including basic operation, application, complexity analysis, and potential pitfalls. Understanding stack operation is essential for designing effective and error-tolerant application. It empowers developers to leverage the stack capabilities and avoid common pitfalls during the application development. Thank you for watching my video. Like and share the video.